Hello, future engineers. This is solutions to plane trusses levels 11 to 15. I plan to provide you with 25 levels of problems. Find the forces in members EF, KL, and GL for the Fink truss shown. So we have a compound truss, and let's apply method of sections this time, or combinations of method of sections and method of joints if necessary. So for the solution, let's have EF here. So because it is mentioned that we have 6 panels at 5 meters, so that means this is 5, 5, 10, and this is a right triangle here. 10 hypotenuse sine of 30, this is 5 meters, the moment arm of EF. Then considering the whole system, because the loadings are symmetrically applied, we can replace them with 20, 20, 20 plus 10 plus 10, 80 kilonewtons here. So MA equals 0. So we can replace it with 80. Remember that this 80 kilonewton load makes an angle with a vertical of 30 degrees with a vertical. And by principle of transmissibility of a force, we can transfer 80 at K. So we have horizontal component 80 sine 30, which passes through A, and 80 cosine 30, which has moment about A. So this distance, by the way, is 5 meters cosine 30, 10 meters cosine 30 rather, 5 plus 5, 10, and cosine 30. So the distance between loads will be half of that, so 5 cosine 30. So call this the vertical reaction at I. The horizontal reaction at I is 80 sine 30 rightward. So that's 40 kilonewtons. This is a rocker, so there's only one vertical reaction. So counterclockwise positive, IV times 30. We will use this later in solving for FFG. So IV times 30, 6 times 5. Then again, imagine that 80 kilonewtons load is shifted at K by principle of transmissibility. The horizontal component passes through A. So it is only the vertical component that has moment. So minus 80 cosine 30 times 5, 10, 15, 20. So 80 cosine 30 times 20. So from there we can solve IV equals 46.188 kilonewtons. Then let's consider all forces right side of this section 111. We can no longer use this 80 kilonewton load here because the 10 kilonewton load is outside of this section because we consider right portion of this cutting section. Then we plan to sum up moment about K because the forces involved are EF, EL, and MK. EL and MK pass through K, so they have no moment about K. So that's the reason. So counterclockwise positive. So MK equals 0 equals FEF, moment arm is 5. FEF, the moment arm is 5. Then plus 20 times this distance is 5 cosine 30 plus 46.188 first times 5, 10, so 10. This is also counterclockwise, so IV 46.188 times 10, distance to K. Then plus 20 times 5 cosine 30. This is 5 cosine 30. This 20 here passes through K, so it's 0. Then this is clockwise, so minus 20 times 5 cosine 30. This is also 5 cosine 30, this moment arm. So you just cancel that. Then lastly, minus 10 times 10 cosine 30, the moment arm. So that's it because this 40 kilonewton here passes through K. So from there we can solve FEF because we can cancel this. FEF is 10 times 10 cosine 30 minus 46.188 times 10. Then the answer divided by 5. So FEF is, it is negative, so therefore it is compression. I just made it positive, then indicated compression, 75.06 kilonewtons compression. Next is KL. KL is here. So let's consider this section. There are four forces involved: MK, KL, GL, and FFG. So I indicated the red ones with the required forces. So take note, there are four forces involved cut through this section, and only two have a common point of concurrency. So which contradicts the principle that if there are four forces, three must meet at a point. But actually, we can still solve this if the equation is not moment summation. Take note that at joint F, by rotation of axis, because EF and FG are collinear, same is true with 20 kilonewtons and FL. So because they are collinear, summation forces along that axis, then we conclude that FEF, which we already computed, is equal to FFG. FEF equals FFG if you sum up forces along this inclined axis here, so that these 20 kilonewtons and FL are not involved in the equation. So conclusion, FFG equals FEL. So therefore, FFG is equal to negative 75.06 kilonewtons also. So that MK, which is horizontal, and GL, which is also horizontal, are not involved in the equation, then our equation would be vertical component of resultant equals 0. So the vertical component of FFG is also the component of FEF equals negative 75.06 sine of 30 because this is 30 degrees. Then plus this FKL, this angle is 60, so plus FKL sine of 60. Then MK and GL are not involved, they are horizontal. Then let's have the forces to the right of this section. So 20, we have positive IV, which is 46.188. Then minus 20, 20, 10, these three forces, their vertical component are multiplied by cosine of 30 because the angle that each of these force makes with the vertical is 30 degrees. So minus quantity 20 plus 20 plus 10 cosine of 30. So FKL can now be computed. It is 50 cosine 30 positive transposed to the left plus 75.06 sine 30 minus 46.188. Then the result divided by sine 30. So from there we can solve FKL equals 40.00 kilonewtons. It is positive, so tension. Then finally, to solve for FGL, so that MK and FG are not involved, because we already found KL, we sum up moment about point I because they meet at I. So moment I equals 0, counterclockwise positive. So just concentrate on the red ones. Blue are not, have no moment about I. So let's begin with FGL. It is counterclockwise, positive. So FGL, this distance is 5, then this angle is 60. So the vertical distance or the moment arm is 5 sine 30. So FGL equals FGL times 5 sine 30. Then this 20 here plus 20 times 10 cosine 30, that one. plus this 20 here times 5 cosine 30, half of 10 cosine 30. So this 10 is not involved, it acts at I. These three forces act at I, so they have no moment. So the remaining force that has moment about I is FKL. So the horizontal component of FKL also passes through I, so it has no moment. Only the vertical component, which is clockwise. The vertical component of FKL is FKL sine of 60, this vertical component. FKL sine 60 and FKL is positive 40, so 40 sine 60, and the moment arm is 5 plus 5, so 10. So minus 40 sine 60 times 10. So we can now solve FGL. 40 sine 60 times 10 minus 20 times 5 cosine 30 minus 20 times 10 cosine 30. Then the result divided by quantity 5 sine 30. So FGL is equal to positive 20 kilonewtons, and it is tension also. So that's it. Determine the force in member BE of the loaded truss. So here's the given figure. So in this problem, this is BE. So there's no need to compute for the reactions. We simply cut sections including BE. Then there are three forces involved, BC, BE, and EF. While EF and BC meet at D, so our plan is to sum up moment about D, considering forces up above the cutting section 1-1. So I denoted the member that is required with red one. So since this is 3 meters and vertically the spacing is equal to 2, 2, 2, 2, so that means this is 2 meters, that's 1 meter. 1, 2, so 3. So that's 1 meter. Therefore, the angle here is, the measure of the angle here is arctan of 2 times 1. Theta. Theta is arctan of 2 over 1. And it is equal to 63.435 degrees. So some moment D is 0. Clockwise positive. The horizontal component of FBE is FBE cosine of 63.435. The moment arm is 2. It is clockwise, so clockwise positive. The vertical component, which is downward, is also clockwise about D. And it is FBE plus FBE sine of 63.435. The moment arm is 1. This vertical component, downward. Moment arm is 1. Then there are only two forces above section 1, 5, and 6. But 6 acts at D, so it has no moment, only this 5. So 5 counterclockwise, so minus 5 times 2. So from here, we can solve FBE. It is equal to 10, 5 times 2, 10, divided by quantity 2 cosine 63.435 plus 1 sine 63.435. So FBE can now be computed. 5.590 kilonewtons positive, so tension. The other way is by principle of transmissibility of a force, for simplicity, so that only one component will have moment about D. So we move FBE through its line of action at B. There are two components, vertical, which passes through D, so don't mind. The horizontal component is FBE cosine of 63.435. So if we use this method, then the solution would be shorter. So still clockwise positive, moment D0. So we have FBE equals FBE cosine 63.45 times 4, 2 plus 2 equals or minus 5 times 2. Take note that 4 is not included. It is below section 1-1. We only consider 1-1. And we just apply principle of transmissibility of a force, although this is transferred to B, but remember, I just applied principle of transmissibility of a force. So minus 5 times 2, then FBE is equal to 10 divided by quantity 4 cosine 63.45, so we'll get the same answer, 5.590 kilonewtons. Determine the force in member DG of the loaded truss. So DG is this one, and we cannot compute DG directly by method of sections. Instead, we still want GH first. Then after that, we isolate joint G. By method of joints, we can solve FDG. So by symmetry of the loadings, the reactions, vertical reactions would be equal to 3L because the total load is 6L. So we have 3L at A. Vertical reaction at B is also 3L. The horizontal reaction is 0 because there's no inclined load. So we considers this section 1-1 and to the left, all forces to the left. So this is FGH and these are the other forces involved. So we sum up moment about D later, moment D0. Since these three loads are still symmetrically applied, we can remove them and replace them with 3L here at E. So theta GH, by the way, is arctan of 4 minus 3, so 1 over 4. 5 panels at 4 feet. So 1 is 4 feet minus 3 feet, so 1 over 4. So this is the angle that GH makes with the horizontal. So we replace this 3 with 3L. We remove them because they are part or they are to the left of section 1-1. So summation moment D or moment D0, counterclockwise positive. There are two components of FGH, horizontal and vertical. The vertical passes to D, so it has no moment, just the horizontal component. The horizontal component is FGH cosine of 14.036 and the moment arm is 3. So equals FGH cosine of 14.036 times 3. Then plus 3L, which is counterclockwise, 3L times 4. Then minus this reaction 3L times 8. 4 plus 4 is 8. So from there, we can solve FGH in terms of L, the load L. FGH is positive 4.123L. Having found FGL, we isolate joint G by method of joints. This is the force in FDG. This is the force in FFG. So the equation is RG vertical equals 0. Then it is equal to FDG upward, then minus downward component of FGH. So minus 4.123L sine of theta GH 14.036. So minus 4.123L sine of 14.036 degrees. So FDG is equal to L, tension. The Signboard truss is designed to support a horizontal wind load of 800 pounds. If the resultant of this load passes through point C, calculate the forces in member BG and BF. So here's the figure. Remember that the load must be transmitted to the joints. This is a distributed load, so let's transform this load into loads into the joints. C is the center, so the tributary area of C is double that of the end joints B and D. So if 800, the total load is 800 pounds, so that means we should divide it by 4 because C receives weight of 2, then B and D 1, so the total weight is 4. So that means at C 400 pounds, at B and D 200 pounds each. So that's it, how to transmit the load to the joints. Then this is BG. So let's consider the section 1-1 and above. And there are 3 forces involved, BG and these parallel forces. So to solve for BG alone, we must sum up forces along an axis. Let's rotate the axis perpendicular to AB and FG. So this is FAB, FFG, and FBG. So the measure of the angle here is arctan of 6 feet over 3 feet, arctan of 2. Then this axis is U, perpendicular to AB and FG and BE. Although BE is not involved because it is not touched by this section here. So this is arctan of 6 feet over 3 feet, arctan of 2. So 63.45 degrees. This is also 63.45 degrees. While this angle here that the 200-pound force makes with the U axis is 90 minus 63.45 degrees is 26.565 degrees, which is equal to this angle here. This entire angle is also 63.435. Therefore, the angle that FBG makes with the U axis is 63.435 degrees minus 26.565 degrees. Use your calculator. It is 36.87 degrees. So all these external loads, 200, 400, and 200 are above the section 11. So we can combine them into 800 again and multiply their components in the opposite direction of U is 800 cosine of 26.565, while the component of FBG in the negative direction of U is FBG cosine of 36.87. So RU equals 0. And let's consider positive in the direction opposite to U. So we begin with FBG. Take note that FFG and AB are not involved. They are perpendicular to this axis U here. They have no components. So FBG cosine of 36.87. Then instead of 200 cosine of 26.565 plus 400 cosine of 26.565 plus 200 cosine of 56.565, let's just make it 800 cosine of 26.565 combined. So from there we can solve FBG. It is equal to negative. So because it is negative, it is compression, 894.4 pounds compression. Next is FBF. We apply method of joints at F, but before that we need to solve FFG. So to solve for FFG, we consider same sectioning and we set moment B0. So take note that this is also 63.45. This angle is also 63.45. I will not indicate it here because it will become complicated. It will overlap with the other figures. So MB equals 0. There are two components of FFG, horizontal and vertical. So this green and BG will not be involved because they act at B. So considering clockwise positive, the horizontal component of FFG passes through B, so it has no moment, just the vertical. The vertical component is FFG sine 63.45. The moment arm is 6 feet, so times 6. Then minus, plus, it is also clockwise, plus 400 times 6, then plus 200 times 12. Now, instead of 400 times 6 plus 200 times 12, because 200 is also above this section 1-1, you may use 800 instead. Imagine that this is 800 times 6. So you can replace 400 times 6 plus 200 times 12 by just 800 times 6 instead. But since I already formulated this, you may have an alternate solution. And let's just continue this. So FFG is negative. FFG is negative 894.4 pounds also. Then we isolate joint F. This is FBF, the other required force. Then this is FEF. Since FEF and FFG have the same angle with horizontal, RF vertical equals 0, we can conclude that they are equal. So FEF sine of 63.45, the vertical component of EF, then minus FFG sine of 63.45, the vertical component of FFG. So we can cancel sine 63.45 and conclude that FEF equals FFG. So because they are equal to negative 894.4 pounds, then we can now have summation, we can now have RF horizontal equals 0, or the horizontal component at F is 0. So leftward positive, so it is equal to FBF, then plus, because these forces are also leftward. Because they are equal, so 2 times plus 2 times the magnitude negative 894.4, take the sine, cosine of 63.45. So from there, so times 2, instead of minus 89 plus negative 894.4 cosine 63.45 plus negative 894.4 cosine of 63.45, that's the same. So FBF is positive, so it is tension, 800 pounds tension. The truss shown is composed of 45-degree right angles. The cross members in the center two panels are slender tie rods incapable of supporting compression. Retain the two rods which are under tension and compute the magnitudes of their tensions. Also find the force in member MN. So we can tell if these diagonal members are in tension or in compression. If they are in compression, then it is 0 automatic. So for the solution, let's have RB here on the rocker. Then here A horizontal rightward 80 kilonewtons. Then A vertical is not important because we plan to section the center panels here and we consider forces to the right of that section. So MA equals 0 to solve for RB, counterclockwise positive. So let's denote the distances. So this must be 2x because the angles are 45-degree triangle, so x, 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 x. So that means this vertical distance is x, then another x, so 2x. So RB times 6x equals RB times 6x plus 80 times 2x, then minus 100 times 4x. So cancel x, then solve for RB. RB is equal to 40 kilonewtons upward. So this is 40 kilonewtons upward. So if we section this panel here, then this should be 60. The shear force of all these inclined members 60, except the horizontal members which have no vertical component. So that should be 60, so that it will be in equilibrium. 40 plus 60 minus 100 is 0, so that's why it should be 60. Then here, it should also be 60 because if you remove that, the shear here should also be 60 upward. So therefore, we conclude that Fn, because the shear is upward, the component of this diagonal should also be upward. So this must be in tension. And EM should be upward also in the direction of the shear, but it is in compression because it is pointing towards the point of application E. So therefore, it is 0 automatic. It cannot resist compression as mentioned earlier. So this member Fn is in tension. Then on this section also, this is upward, so it is compression, so it is 0. So in this situation here, in this panel here, GM is in tension. So that's why it is away from point of application. So let's go back to here. That is MN, force in MN. So considering this section here and to the right, to solve for Fn, remember this is 45 degrees, just set R vertical equals 0. The vertical component of the resultant of the forces to the right of this section here, 0. And it is equal to the vertical component of Fn, which is FFn sine 45, plus RB, which is 40, and minus 100. So from there, we can solve FFn is equal to positive, of course, because it is a tension member, 84.85 kilonewtons. In the same manner, we can show that FGN is also 84.85 because the equation is the same, RV vertical equals 0. So FGM sine 45 vertical component plus 40 minus 100, then FGM is also 84.85 kilonewtons tension. And finally, for FMN, let's go back to this section here. We sum up moment about F so that Fn acts there. We can also have summation forces X instead, but let's just have moment F0. So clockwise positive. So Fmn times X, moment arm, then plus 100 times X also, then minus RB, which is 40 times 3X. X plus X plus X is 3X. So from there, we can solve Fmn, cancel X, is equal to positive 20 kilonewtons. So it is also tension. So that's it for this level 15. Let's have levels 16 to 20. Then I plan to have levels 21 to 25. The challenging trusses will be there.